Hi, in this lesson we continue to look at our number system. We start off by looking at decimals and how we can round them off and how we can convert between decimals, fractions and percentages. Then we look at square roots and we discuss this a bit, and then we go on to look at rational numbers and irrational numbers and see where these all fit into our system of real numbers. We then conclude by discussing briefly how we can locate numbers on the number line, and we look at when numbers are increasing or decreasing. Okay, so let's get started. I'm sure you're quite used to working with decimals. Let's say 0.3, 0.005, right? These are two examples of decimals. And what these have in common is they're both the equivalent of fractions, in which the denominator is sum. So a fraction is sum a over b, and in this case the denominator is some whole number power of 10. So this then can be written as 3 over 10, right? In which case then it's 10 to the first power. And of course this can be written as 5 over 1,000. In this case, this is 10 to the third power. Of course, if you have a number like 7, that's really 7 over 1, in which case that's the same, then this is 10 to the 0 power. All right. If you have numbers like 2.16, this can be written as a mixed fraction, 2 and 16 over 100. Of course, you can easily see that we could also write this as an improper fraction as 216 over 100. The point is the denominator is some whole number power of 10. We now look at how we round off decimals. Let's say you're given the number 18.379 and asked to round this number off to the nearest hundredth. Well, you look for the hundredth place, and that's this place here. So you can mentally, you don't necessarily literally have to write a little arrow like this, but you come and you focus here. This is the hundredth place, and you look at this number here and you say, well, if this number is equal to 5 or more, if this digit is 5 or greater, then I'm going to increase this number by 1. If this is less than 5, I'm going to decrease by 1. So here, obviously, this is greater than 5, so this is increased to 1, so that becomes 18.38, and then all the digits after this I ignore. We could also ask to do this to the nearest 10th, and so then we do the same thing here now, only that I'm focusing on this place, the 10th place. And likewise, I look at the number after it and I say, well, that's 18 point, and this is greater than 5, and so that becomes 4, and then I ignore the rest. Of course, we could also ask you to round this off to the nearest whole number, in which case then we focus here. And so then we look at this number and we see that this is less than 5. So this then is going to be 1/8, and we leave that like that. Notice we look at the number afterwards. This is less than 5, so this remains the same. So if the number to the right of where you're focused is 5 or more, then you increase the number that you're focusing on by 1. In this case, we have this number, and let's suppose we want to round off this number to the nearest thousandth. So let me write that here. So this would be the place that we'd be focused on, and we come and look beside it, and we see we have the number 5. So remember, the rule is if this number is 5 or greater, then we have to increase this number here. So then this becomes 17.219. So there are many other examples we could do, but if you do class with me, we'll do those in class. Another thing I want to point out here is that this rule, or these rules that we see here, are not the only rules that exist. So for example, accountants have a different way of rounding off, and we won't get into that. Perhaps you can look it up and see it for yourself. Likewise, we don't always tell you like round off to the nearest thousand or hundredth. You can round off in terms of significant figures. Now, we haven't discussed significant figures in this video, so that's something I leave for another time. But even when they tell you to round off to a certain number of significant figures, you are still going to end up, based on that, identifying some place. And then once you locate your place, then you apply these rules or the slightly different rules which accountants use. Alright, so let's move on to the next topic. Let's look at how we can convert a decimal to a fraction. So suppose you're given the number 0.374 and you're asked to express this as a fraction. Well, what you do is you look for the last decimal and identify its place. So this would be the thousandths place, which means then that in your denominator here you're going to have 1,000. And then you just write these digits, 374. So I think that should be straightforward enough. Now, if you're asked to do the opposite, if you're asked to convert a fraction to a decimal, let's say you have 3/4. Well, you simply carry out the division, and this would be the same as what? Well, 0.75. So you just say 3 divided by 4. So you could do that by hand using long division, or just simply use a calculator. Note that sometimes you have this little difficulty here. So for example, if I have 1/3 and you say 1 divided by 3, you're going to get 0.333 forever, right? So some books tell you that when you see this, you put a little bar like this, and that's fine. I personally don't subscribe to that, but maybe it's because I don't think that approach existed when I went to school. So I would just pick a certain number of decimal places that I find, convenient, and maybe I do a little thing like this to show that it's equivalent. That it's approximate. Okay, so I think that about covers that. It is important that you understand that a percentage is simply a fraction in which the denominator is 100. So 5% is really simply 5 hundredths. 5%, 5 hundredths. So we make use of this fact when converting from decimals to percentages and vice versa. So let's suppose we have the decimal 0.375. To get this as a percentage, all I need to do is, well, divide it by 100. Notice I have a fraction now in which the denominator is 100. But if I leave it like that, I have changed the number, so I need to multiply it by 100 also. Notice what I've done here. I've simply taken this number and multiplied it by 1. I can't emphasize enough how important it is to always recognize this fact when it is occurring. Right? I'm simply multiplying by 1. If I multiply by 100 and divide by 100, or divide by 100 and then multiply by 100, in effect I have multiplied by 1. So the result of this then has to be the same, right? And so then this becomes what? 37.5 over 100, which then is of course then 37.5%. So it's important that you not only know little steps like how you do something. I really have a problem with math being taught that way, that you know how to do this and how to do that. It's important that you know how to do things, but it should be based on some understanding of what's going on. So if I have 0.628, you can look at that and simply say then that's going to be what? 62.8%. And don't just learn the steps like, okay, you move this 2 decimal places to the right and put a percentage sign. There's no mathematics in that, right? I hope you understand that, right? That's just giving you like some steps that you may or may not remember after a while. So why does this work? Why does moving 2 decimal places to the right give us the answer as a percentage? Because by moving this point 2 places to the right, what I have done in effect is multiplied it by 100, and then putting the percentage sign is like dividing it by 100. You see it? So when I move this 2 places to the right and put a percentage sign, what I have done is multiplied it by 100 and divided it by 100. So when I multiply it by 100, I get 37.5 divided by 100, 37.5%. Likewise here, this can become 0.628 times 100 divided by 100. And so what this does here is it moves the decimal place to 2 places to the right, and then we express this as a percentage. So I urge you to really try and understand what's going on in your mathematics courses, as opposed to just memorizing, well, this is how you do it and that's how you do it. I've had students come to me and ask me to show them how to do something, but without explaining it, they don't want to understand it. Don't do that, don't do that. Of course, going from a percentage to a decimal is very easy. So let's suppose you have 28%. Well, that's simply 28 over 100, which of course then is 0.28. If you have, let's say, 2.4%, well, that's 2.4 divided by 100, which is then 0.024. Notice then that what we're doing here is simply moving the decimal point 2 places to the left. Understand what that means, right? When you move the decimal point 2 places to the left, you're dividing by 100. Let's talk about squares and square roots. We know that 8 squared is equal to 64. So we can say that 64 is the square of 8. We know that minus 8 squared is also equal to 64. So we can also say that 64 is the square of minus 8. There are other things that we can say here also. We can say that 8 is the square root of 64, and we can also say that minus 8 is a square root of 64. So I said the just now, I probably should have said a. So 8 is a square root of 64, minus 8 is a square root of 64. Now we need a notation. So if I want to talk about the notation, if I want to talk about the square root of 64, and then I simply go like this. And of course the square root of 64 can be equal to 8 or minus 8. However, when we use this notation here, we are always referring to the positive square root. So this is 8. This is never minus 8. If I want to refer to the other square root of 64, then I gotta say it's the negative of this, and of course then that will be minus 8. Alright, so the square root of 64 is then, it can be plus or minus the square root of 64. That gives us plus or minus 8. So we'll see more of this later on, especially when we get into quadratic equations and stuff like that. So be aware that whenever you see the square root sign like this of, let's say, 25, we're referring to the positive square root. So that's what we're saying here. Also be aware that there is no number in a set of real numbers such that when you square it you get minus 25. So this is not in the real numbers. So later on we'll take a little look at what is unfortunately called imaginary numbers, and well, when we get there we'll look at that. But instead of real numbers, the square root of minus 25 does not exist, because there is no real number such that when you square it you get minus 25. There is a real number such that when you square it you get 25, and that's 5. A rational number is any number that can be expressed as the ratio of two integers. So for example, 3/5 is a rational number, 0.67 is a rational number because that can be expressed as 67 over 100. 1/2 is a rational number. 8 is a rational number because this can be expressed as 8 over 1. Minus 3 is a rational number because it can be expressed as minus 3 over 1. So these are the rational numbers, and with the rational numbers we expand our number system, because now, first we started off with the counting numbers, which were 1, 2, 3, 4. Then we have the whole numbers 0, 1, 2, 3, 4, and then we have the integers, which are go to negative and positive infinity. So it's all the negative whole numbers, and all the positive whole numbers, and 0. And those would be the integers. And so the rational numbers include all of these and numbers in between. Right? So you have numbers in between these. So for example, between 1 and 2, you have rational numbers like 1/2, right, and 3/4. These are between 0 and 1. Between 1 and 2, you have, let's say, 3 over 2, 7 over 5. Right? So these are rational numbers found between 1 and 2, and 1/2 and 3/4 are rational numbers found between 0 and 1. And you can find rational numbers all over, the number line. Now we come to a very important concept, the irrational numbers. And so not every number between integers are rational numbers, because not every number between integers can be expressed as a ratio of two integers. So for example, pi cannot be expressed as some number divided by another, where these are both integers. Now in primary school you may have been taught 22 over 7, but that's just an approximation, right? Another very classic example is the square root of 2. Square root of 2 cannot be expressed as the ratio of two numbers. So that came as a surprise to some people, and if you go back 2,500 years, the Pythagoreans refused to accept that you had numbers that could not be expressed as a ratio of two integers. So be aware of that, right? You have irrational numbers, and an irrational number is a number that cannot be expressed as the ratio of two integers. Now, how can you recognize rational numbers and irrational numbers? Well, one way is to look at the decimal form. If the decimal form repeats, so for example, if you have 0.33333 going on forever and ever and ever, right, then that's a rational number, right? Or if it stops, so 0.3 like that, well, that's a rational number. That's 3 over 10. 0.33, well, that's 33 over 100, right? And of course, 0.3333 forever, that is 1/3, right? And I'll probably ask you in an assignment to prove this, right? That if this number repeats forever, then it is a rational number, and in this case it's going to be 1/3. So as long as the decimal form has like a repetition that continuous repetition is always there, or it stops somewhere, it's a rational number. Now if it does not repeat and does not stop, then it's an irrational number. So let's look at pi. Pi, we can start off looking at pi as 3.141592, and it goes on and on and on, and you will never find a group of integers, or I should say a group of digits that repeat forever, right? So then pi is irrational, right? Likewise with square root of 2, right? You will never find it doesn't stop. So there are two things, right? It doesn't stop and it doesn't repeat. There's no repetition of any group of digits, and so then this is irrational, and this is also irrational. That's 1.14, sorry, 1.414213, and it goes on forever and ever. And you're never going to find a group of digits that continuously repeat. Alright, so a very important note. If you are asked to define a rational number, don't use this as the definition. This is not the definition. This is just an aid to recognizing rational and irrational numbers. The definition of a rational number is a number that can be expressed as a ratio of two integers. And the definition of an irrational number is a number that cannot be expressed as the ratio of two integers. So these are like consequences of that fact. Right? Okay, and so then we look at the real numbers. And so the real numbers are all the rational numbers and irrational numbers. So that gives us a pretty big number system now then. So in this course we're going to be working for the most part with real numbers. And real numbers include what? The rational numbers and the irrational numbers. And of course the rational numbers include the integers and the whole numbers and the counting numbers. Here we have a summary of our number system as we know it thus far. The real numbers are divided into two groups, the rationals and the irrationals. Within the rationals you have your integers, your whole numbers, and your counting numbers. So now be aware, right? Any counting number, any whole number, any integer is a rational number. However, you can't say that every rational number is an integer, obviously, because some rational numbers, like 1/2, is not an integer. So just be aware of that, right? Later on, we'll expand our number system. So here we have the real numbers. Later on, very briefly, we'll look at what are called the complex numbers. And that then will give us our entire set of numbers. It is very important to be able to locate fractions and decimals on the number line. At least to have a good sense of where the number is located. So for example, -5 3/8 has to be somewhere in here. -9 1/2 is, right between here. 5 1/4 is somewhere in here. If you have numbers with different denominators and it's hard to say, which one is greater than the other, the easiest way to resolve that would be to express them in decimal form. And so you can simply use your calculator and get the decimal form, and then you can see which of the two numbers is greater, relative to each other. One more very important point I want to make is the following. Remember, mathematics is about numbers for the most part, and so you have to understand numbers, and there are some very simple things that sometimes students get wrong. Let's take a look at these numbers over here. -10 is less than -2. Now, I've had students say -10 is greater than -2, but it's negative or something like that. No. This is very simple. Numbers to the left are always less than numbers to the right. Numbers to the right are always greater than numbers to the left of them. So, -2 is greater than -8. 0 is greater than -9. 0 is greater than -100. -8 is less than -1. -1,000,000 is less than -1. So let's get that clear, right? So especially it's with these numbers that students sometimes have difficulty. Positive numbers, I don't find that so much to be the case. So for example, 1 is greater than -10. 7 is greater than -10. 7 is greater than -1. Numbers to the right are greater than numbers to the left. So if you have some variable and the value of the variable is increasing, then as the numbers vary in this way, you go from -10, -9, -8, that number is increasing. And in this, so that's increasing. No matter where, right? That's increasing, right? As long as it's to the right, and this way, decreasing. Right? So this is very, very important. So make sure you grasp this. Alright, so that brings us to the end of this video. It's been a pretty long one, I think. So if you've made it this far, thanks for your attention. Okay, so bye for now.